The periodic table of elements is one of the most significant achievements in the history of science. It organizes the known elements into a coherent framework that reveals their properties and relationships, serving as a cornerstone for chemistry, physics, and material science. By the early 19th century, chemists had identified around 60 elements, including gold, silver, copper, and oxygen. However, there was no systematic way to organize these elements or predict their properties. Scientists needed a framework to make sense of the growing body of chemical knowledge. John Dalton's atomic theory, 1803, laid the groundwork by proposing that elements were composed of indivisible atoms with unique masses. This theory emphasized the need to group elements by their atomic characteristics. Before Dmitri Mendeleev's groundbreaking periodic table, several scientists made critical contributions. Johann Dobereiner, 1817, introduced the concept of triads, groups of 3 elements with similar chemical properties, and noticed patterns in their atomic weights. John Newlands, 1864, proposed the law of octaves, observing that elements arranged by increasing atomic weight displayed repeating properties every 8th element. Though insightful, this idea was criticized for oversimplifying chemical relationships. Lothameyer, 1869, independently created a periodic table based on atomic volume and atomic weight, showing periodic trends in properties. His work paralleled Mendeleev's, but did not gain the same recognition. In 1869, Russian chemist Dmitri Mendeleev published the first widely recognized periodic table. His approach was revolutionary for arranging elements by atomic weight and predicting missing elements, which were later discovered. Mendeleev proposed that the properties of elements are a periodic function of their atomic weights. He accurately predicted the properties of elements like gallium, germanium, and scandium, which fit perfectly into his table. While Mendeleev's table was groundbreaking, it was not the final form. In 1913, Henry Moseley showed that the properties of elements are better explained by their atomic number rather than their atomic weight, resolving inconsistencies. The discovery of noble gases added a new column to the periodic table. Lanthanides and actinides were incorporated into a separate section below the main table to avoid disrupting its structure, evolving into its current form. The periodic table has guided the discovery of new elements. Since Mendeleev's time, dozens of elements have been added, including synthetic elements like technetium and the transuranium elements. The periodic table provides a framework for understanding chemical reactions and bonding. By grouping elements with similar properties, it simplifies the study of chemistry and is essential in physics, biology, and materials science. As a visual representation of chemical knowledge, the periodic table is a cornerstone of science education, helping students grasp the relationships between elements and underpinning advances in areas like quantum mechanics and nanotechnology. Modern versions include 118 confirmed elements, with the most recent additions being nihonium, moscovium, tennessine, and oganesson. These super-heavy elements were synthesized in laboratories, pushing the boundaries of chemistry and physics. Ongoing research focuses on discovering new elements and understanding the limits of the periodic table. The invention of the periodic table was a monumental milestone in science, transforming our understanding of the elements and their relationships. From Mendeleev's visionary framework to the modern table's intricate details, it continues to serve as a universal tool for exploring the building blocks of matter, a testament to human ingenuity and our quest to decipher the universe's principles.